Welcome back everyone, your academic coach here. Today I'm going to talk about key features of a function. Again, if you're taking Algebra 1 or Algebra 2, even pre-calculus, this video will benefit you. So in part 1, I talked about the fundamental definition of a function. Recall that the function is a very special relation between two sets of data, inputs and outputs. So we define a relation as a function when each of the input corresponds to only one output. So this is an example of a function. For each of the input, there is only one arrow pointing away. Whenever we talk about functions, we always talk about domain and range. Then what are domain and range exactly? Domain represents all the possible inputs, and range represents all possible outputs. Sometimes we use all possible x values and all possible y values to represent them, but actually x and y, they are just conventional variable used to represent input and outputs. You can also use u and v to represent the inputs and outputs. Then why do we need to learn about the domain and range? The reason we apply a function in real-world situation is because when you're given an input, you want to find the corresponding output, or when you're given an output, you want to go back and find the input. Then you need to know what are the possible range of these inputs and outputs. If you're trying to plug in an element which is not even in the domain, then you don't even have to try element in the function because I know for sure that it's not going to work. Let's say this is a boba shop and then there are 4 different menus, 1, 2, 3, 4, and then ABC represents 3 different types of boba. And let's say here is a customer who is trying to order number 5 boba. But number 5 is not even on the menu. No matter you try to order it on kiosk or you try to ask the cashier, you will never get a corresponding product. Why? Because there's no such element in domain, which means there is no corresponding element in the range. There's no corresponding menu for number 5. So I don't even have to try to order it on kiosk. Now let's talk about an actual high school mathematics and algebra class. How do we actually find the domain and the corresponding range? So here is a really simple linear function, y is equal to x minus 1. Now I want to find the domain and range for this function. Again, domain means all the possible inputs or all the possible x values. Then how do I find it? What I do is I will try to spot a few points on this linear line. Again, domain means all the possible x values. So for now, I don't have to care about y values. All the x coordinates of these points are 5, 1, 0, negative 4, which means all of these are in domain. But are they the only elements in domain? No. Any points in between them can also be the domain. So any point between 1 and 5, not just 2, 3, 4, 2.5, 3.9, 4.0003, or 4.999, any of these values can be in the domain. But are they the only elements in the domain? No, because this is a linear line that extends in both directions infinitely. So I can plug in a lot of the other x-coordinate values. What you do is you try to draw this vertical line from all of these points on the line all the way to the x-axis. When I try to draw this vertical line to the x-axis, then I find a corresponding x-coordinate. Now this corresponds to number 5. This corresponds to number 1. This corresponds to number 0. This corresponds to number negative 4. Let's say I'm going to spot one more point here, negative 6, negative 7. Then it corresponds to x is equal to negative 6. And then on this x-axis, let's consider it as a number line. And then you're trying to spot all of these x coordinates. Then you will realize that any real numbers along this number line, along the x-axis, can be the x values, because this linear line extends in both directions infinitely. So when you're trying to draw all of these, so when you spot any of the points along the line and then draw the vertical line all the way to the x-axis, it corresponds to every single point on the x-axis, which are all the real numbers. Then how do I write this out? Because I don't want to write in regular English. I want to represent it in terms of the mathematical language. So there are 2 different ways. One is set notation. The other one is interval notation. The set notation. So we use this capital letter R to represent the set of all the real numbers or the capital letter Z to represent all the integers, or I use the capital letter Q to represent all the rational numbers because we use variable X to represent the input. So X is an element of the set real number, which means X can be any real numbers. The second one is the interval notation. So interval notation means I'm gonna set the minimum and maximum of the output values. When X can take all of the real numbers, then what is the maximum that X can take? There is no such a maximum. X can be infinity. What is the minimum? There is no such a minimum. X can be as small as possible, which is negative infinity. So now I'm going to use the positive infinity sign and negative infinity sign to represent this. But instead of using X, now I don't care about the variable. Now I'm going to use either the parenthesis or the bracket. So parenthesis means less than or greater than. The bracket means less than or equal to, greater than or equal to. So X can be as big as a positive infinity. So I'm going to put positive infinity on the right side, and X can be as small as negative infinity. So I put negative infinity on the left side. Parenthesis negative infinity, comma, positive infinity, parenthesis. This is translated to X is greater than negative infinity and less than positive infinity. Why don't we use the equal sign? Less than or equal to or greater than or equal to. Infinity or negative infinity, these are just a symbol. They are not specific numbers. They are just a symbol to represent an infinitely big, infinitely large number or infinitely small number. They can never be a specific number. Let's say there's a very, very, very large number such as 1,000 trillion, but when you add 1 on top of that number, then this new number becomes a bigger number. So infinity can never be a specific number. So when it comes to infinity or negative infinity, we always use less than or greater than sign. So we always use the parenthesis rather than bracket when infinity is involved. Then what about range? Again, as for the range, it's exactly the same. We can use either set notation or the interval notation. Again, I'm going to spot these points. And this time, instead of the x coordinate, I'm going to focus on the y coordinate. So the y coordinate of these points are 4, 0, -1, and -5, -7, and then it goes on. And how I can visualize it is by connecting these points on the line all the way to the y-axis. You get 4 and 1, 0, you get 0, -1, you get -1 and -5, -7, and then it goes on. So eventually, because this line extends in both directions infinitely, when you draw this horizontal line to y-axis, you will observe that every single point along the y-axis can be the y-coordinates, which means the range is all the real numbers again. How we represent it is going to be exactly the same. Either we use the set notation, so it becomes y is an element of the real number set, which means y can be any real number, or we use the interval notation. Again, all the real numbers means that y takes any value between infinity and negative infinity. So we use parenthesis negative infinity, comma, positive infinity parenthesis to represent the range of this function. Here is another example. This is a quadratic function. And again, I want to find domain and range. So domain represent all the possible x values. Again, what I do is I spot all of the possible points on this graph, and then I draw the vertical line to the x-axis, and then I find the corresponding x-coordinates. So let's say these x-coordinates are -4, -3, -1, 1, 3, 5, 7, and then it goes on. Now again, you observe that every single point along this on this graph corresponds to all the possible real numbers, all real numbers along the x-axis. You can take any value between -1 and 1, between 1 and 3, between 3 and 5, and then because this graph extends in both directions infinitely, it's going to extend all the way to the right, so it can take as many x values as possible. It can take as large x values as possible and as small x values as possible. It can take some really large numbers such as 99, really small numbers such as -1,000, -10,000, and then it goes on. So again, when we use the set notation to represent the domain, x is an element of all the real numbers. Or when I use interval notation, then it becomes parenthesis, negative infinity, comma, positive infinity, parenthesis. Now it comes to the range. It gets a little bit tricky here. Draw the horizontal line to the y-axis. And then let's say these values corresponds to negative 3, negative 1, 1, 3, and then it goes on. Because this function extends in both directions infinitely. So when you take these points on the graph and then draw the horizontal line to the y-axis, you can take as many y values as you want. You can take all the positive y values or when it comes to negative y values, you cannot go down as much as you want. And then these points corresponds to the y coordinate until negative. This means that the minimum of the y values that you can take is negative 3. If I use set notation to represent this, then y is greater than or equal to negative 3. Here, I do not have to write the real numbers symbol again, because when I just write y is greater than or equal to negative 3, it assumes that it takes all the real numbers that is greater than or equal to negative 3. This is an assumption that we use in high school mathematics. Or you can try to use the interval notation. Interval notation needs to specify the minimum and the maximum. And now the minimum is negative 3. Then it becomes negative 3, comma. There's no maximum, so it's positive infinity. I know that for the infinity, it must be the parenthesis. But what about negative 3? Y is greater than or equal to, because of that equal sign, y can take negative 3. So this time, instead of using the parenthesis, I use the bracket. So bracket means you are including this number. So this means y is greater than or equal to negative 3 and less than positive infinity. So y cannot never take a number called infinity because it's not a specific number. Here is another example. What about this function? What is the domain and range? Domain represent all the possible x values. So what I do is I spot all the possible points, all of the points on this graph, and then try to draw the vertical line to the x-axis. And then you observe that the x values can be all the real numbers except at x is equal to 0. Then when it comes to the set notation, you can simply put x. So when it comes to set notation, rather than put x is greater than 0 or x is less than 0, you can just simply put x is not equal to 0. It means x takes all the real numbers other than 0. What about the interval notation then? When it comes to interval notation, it can be a little bit complicated. Well, we know that x coordinate can be as small as possible, and then it can take all of the real numbers all the way until just less than 0. So that is x is less than 0 or as large number as possible, and then it can take smaller numbers all the way up until x is just greater than 0. So x is either less than 0 or greater than 0. And now I want to represent it in terms of interval notation. Well, when x is less than 0, there is no minimum. So on the left side, I put parenthesis and negative infinity. Parenthesis, negative infinity, comma, 0, and then here's a parenthesis. For x is greater than 0, parenthesis, 0, comma, positive infinity, and parenthesis. Well, how do I connect them? Because I cannot just put a comma or plus or just or. So we are going to use U to represent it. U stands for union. It can also mean or. It means x is either in or in this set. Now let's talk about range. I'm going to plot out all of the points along the graph, and then I will find the corresponding y coordinate by drawing this vertical line. So when you try to draw all of the vertical line to the y-axis, you observe that y can take as large values as possible, but it cannot take any value that's between 2 and negative 1. So if I ever use the set notation, then the range is y is either greater than 2. Y can never take 2 because this curve will never touch y is equal to 2. They will be infinitely close to each other, but they will never cross or touch each other. So y is either greater than 2 or y is less than negative 1. Y can take as small values as possible, but it cannot take any values that's above negative 1. So this is the set notation. Then what about the interval? As for the interval notation, I'm going to start from the small number all the way to the big number. Remember that for the interval notation, it's always the minimum, comma, maximum, minimum, comma, maximum. So I'm going to start from this one. Y is less than -1. Y can be as little as negative infinity. Infinity is just a symbol. You can never find a number that's equal to negative infinity. So we put a parenthesis rather than bracket. So parenthesis negative infinity, comma, -1. Y does not take -1. There's no equal sign. So it's parenthesis rather than bracket. We use the union symbol to represent or. And then y is greater than 2. Now this one comes easy. Parenthesis, because there is no equal sign, parenthesis 2, comma, positive infinity, parenthesis. So this is how you find the domain and range of a function. And now let's talk about the increasing and decreasing of a function. When you identify if a function is increasing or decreasing, it's just like incline versus decline. But remember that you always go from left to the right. So this is increasing and this is decreasing. If you ever have a graph like this, then it's increasing on the left side of this point and it's decreasing on the right side of this point. Some of my students raised a question to me before and they claimed that, oh, I think this is decreasing for the whole interval because this is the maximum point and then you can go down to the left or you can go down to the right. Okay, that's a very creative way to think about it. But we only counted when you go from left to the right. The direction is always going from left to the right. So from left to the right, you're walking up all the way to 1, 10. So this part is increasing. And from 1, 10 to the right, it's always going down. So this part is always decreasing. A lot of times it's asking you to write down the intervals for increasing and interval for decreasing. It's actually asking for what values of x is this function increasing and for what values of x is this function decreasing. Okay. So we know that 1, 10, this is the point that separates the increasing part and decreasing part. And anything to the left of this point is increasing. But I do not care about the y coordinate. I only care about the x coordinate when I talk about the interval. I only care about the inputs because output is not something you can always predict. But input is always something that you can predict or you can control. So we focus more on the inputs. So interval of increasing, either you can use the set notation to write it as x is less than or equal to 1, or you can use the interval notation to represent it as parenthesis negative infinity, comma 1, bracket. The interval for decreasing it will be any part that's on the right side of 1, 10. So x is greater than or equal to 1 if you use the set notation, or if I use the interval notation, then it becomes bracket 1, comma, positive infinity, parenthesis. And then let me talk about x and y-intercept, which are also one of the most important key features of a function. So x and y-intercepts represent the points at which the function crosses the x-axis. X-intercept occurs when y is equal to 0, and y-intercept occurs when x is equal to 0. So this is a random function that I just draw. Then this function has one y-intercept here and one x-intercept here. Okay, think of any of the points along the x-axis. This is 0, 0. This is -5, 0. This is 3, 0. This is 7, 0. Any points along the x-axis has one thing in common, which is all of them have the 0 as their y-coordinate. And that's the same for the x-intercept. So that's why we always put y is equal to 0 or fx is equal to 0 and then start from here to solve for the corresponding x. Then the corresponding x coordinate, comma 0 is the x-intercept that we're looking for. And that's the same for the y-intercept. This time, let's think of any of the points along the y-axis. It can be 0, -4, 0, -3, 0, 1, 0, 2, and then it goes on. And that's the same for the y-intercept. All of these points on the y-axis have one thing in common, which is they have 0 as the x-coordinate. So we know that x is equal to 0, so we plug this in. So the corresponding y-coordinate is going to be f0, and then you get whatever the value. Then 0, this y-coordinate is going to be the y-intercept. sometimes when I ask my students, what is the y-intercept, they give me just one single number. I know what they mean, but this is not an accurate way to represent the intercepts, because either y-intercept or x-intercept, they represent a specific point, and any point on the xy plane must be represented in terms of x coordinate and y coordinate, which represent the position in terms of x and the position in terms of y. So giving me just one single number does not actually represent its position in xy plane. So the correct way to represent x coordinate or y coordinate is going to be a number, 0, or 0, some number. The last but not least is going to be the maximum or the minimum. Well, in AP Calculus, we will talk more about the maximum and minimum, including the local minimum, local maximum, and absolute minimum. But here we only deal with the absolute maximum and absolute minimum. So let's say this is a function fx. Then how do we find the maximum and minimum? When we talk about maximum and minimum, we always refers to the maximum outputs. The output is either maximum or the output is minimum. I do not care about the input. I'm not talking about the biggest input or the smallest input. I'm talking about the biggest output and the smallest output. Then how do we find it? Try to draw a horizontal line. And then try to move this horizontal line across, up and down across the graph. And then when this horizontal line still has intersection with a graph, then try to find the maximum point and try to find how high it can go. Okay, so if this horizontal line goes above than this point, then there is no intersection. So this is the maximum that it can go. Then it still has an intersection at this point, and then it crossed the y-axis, and then it crossed the y-axis at this point. So the coordinate of this point represent the maximum of this function. Let's say this point has a coordinate of 3, 7, then the maximum for this function is 7. I do not care about 3. On the other hand, how we find the minimum is exactly the same. Again, using a horizontal line, I move it up and down, and then I try to find a point at which this line still crossed the graph, yet it's at the lowest point. Now I found this. Let's say this point has a coordinate of -1, -3, then -3 represent the minimum of this function. Just try to be careful, because sometimes you will observe the maximum or minimum on the endpoints of the function. And let me give you a brief introduction to all different types of the function that you learn in high school math. So linear quadratic polynomials. We know that linear means it's y is equal to x plus something. Quadratic means it's y is written in terms of the x squared. Polynomial means y is written in terms of x to the power of n, where n is any of the natural number. And rational function, which is also named as reciprocal function, because y is represented as the reciprocal of x, 1 over x, or 1 over x squared, or 1 over x plus 3, something like that. And radical function, also given a name of root function, means there is root involved. Y is equal to square root of x, or cubic root of x, or even tenth root of x, and then it goes on. Exponential and logarithmic, they're a pair of inverse functions. So exponential function means y is you're raising x in the power of, you're raising x to the power of e. You're raising e to the power of x, or you're raising a constant to the power of x. Logarithmic function means y is equal to log x, or ln x, or log x in the base of 10, etc. And then the next is trigonometric function that you learn in pre-calculus, cosine tangent, and then we also have secant, cosecant, cotangent, and we also have the inverse trigonometric functions. So there are 12 different types of trigonometric functions in total that you need to learn. And absolute value functions and greatest integer functions are something that you don't see that often, but still they are considered important. So absolute value function means y is equal to absolute value of x. It has that V-shaped. Greatest integer function, it has this staircase look. So you are taking the greatest integer, which is less than or equal to the given input. So I will talk about each of the functions later in separate videos in detail.